existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. They've already wiped out the dinosaurs and many other species. And there's no doubt they will strike again.
It would be a disaster far beyond biblical proportions.
Investigating asteroids isn't just about science.
Asteroids are going to be one of our biggest problems for humanity.
It's about survival.
So the smarter we can get before then, the more we can figure out, can we do anything about it?
Get ready for the latest asteroid discoveries and daring new plans to go where no man has gone before. It's the year 2029, and an asteroid that scientists have been tracking for decades is passing close to Earth. The asteroid is about 3 football fields wide. Its name is Apophis, after the ancient Egyptian god of destruction. According to the latest predictions, Apophis won't hit Earth in 2029. But as it passes through a seemingly nondescript area of space nearby, the world's scientific community goes on high alert.
Astronomers have calculated a very small region of space, which if Apophis happens to go through that region, then it will be set up for a collision with Earth in 2036. And this very, very tiny region, which is less than a mile across, just a few thousand feet across, is called the keyhole.
An international cooperative of space agencies launches a rocket to take on Apophis.
Now, you don't want to blow it up with a nuclear weapon. First, that would take a lot of energy, and it would just produce a huge number of fragments all heading toward the Earth. What you really want to do is give it a bit of a push that slightly changes its trajectory. That way we don't get a collision.
But it's possible that the 30-million-ton space rock could simply be too massive. The collision hasn't knocked the asteroid far enough off course. The impact in 2036 is thousands of times stronger than the atomic bomb dropped on Hiroshima. The immediate crater is as wide as the island of Manhattan.
It would create a crater over 2 miles wide. If Apophis were to hit a city, goodbye to that city and the surrounding region for 100 miles.
From the shock wave, the blast, the winds coming out, from the impact ejecta, and from the massive earthquake equivalent that would occur, that would reach out and be felt over huge areas.
When Apophis was first discovered in 2004, the initial odds of an impact were about 1 in 37. But those odds have been dropping over the years, as scientists have obtained a better look at its path.
You can make the analogy that the orbit determination process is similar to predicting hurricanes. When a hurricane first starts out, you don't know exactly where it's going to go. And as you get more and more data in the next week or two, you can refine your predictions. And so it's very much like that with asteroids and comets. The more observations you get over time, the better you know where the object will be in the future.
That's why today's odds of an Earth impact, only 1 in 250,000, are so much slimmer than the original 1 in 37 prediction. But even if Apophis doesn't hit Earth, there's no doubt that something else eventually will. It's a disaster that space agencies take very seriously. In July 2010, a NASA advisory panel recommended the creation of a planetary defense office to figure out how to detect and deflect any asteroids heading our way.
We know for a fact that an asteroid is going to impact the Earth sometime in the next 1 to 10,000 years, a big one. And it's a good question as to when it's going to happen and are we going to be ready for it when it does.
A seaside amusement park is an unlikely place to demonstrate how asteroids and comets speed around our corner of the universe. But an arcade attraction here actually reveals a lot about these deadly objects.
Our solar system is kind of like a shooting gallery. Asteroids and comets can occasionally hit planets and moons, creating gigantic impact craters. Now, the bigger objects present a larger cross-sectional area, so they're easier to hit. In this case, I actually have to hit these little bullseyes, which are all about the same size, but imagine that the man over there is Jupiter. He's big, and the chipmunk might be the Earth, smaller, and these ants might be our moon, even smaller. So Jupiter is pretty easy to hit. Earth, the chipmunk, is harder to hit. It's a smaller cross-sectional area. Ah, there it goes. Earth was hit. The ants are small, so they're even harder to hit. Most of the asteroids miss. Only occasionally do they hit.
But unlike the shooting gallery, where the bullets, or in this case flashes of light, always travel in straight lines, asteroids and comets curve toward their targets.
Jupiter tends to draw in the asteroids and comets through its gravity. So it's kind of like if I start with my aim way over there, Jupiter pulls the barrel of the rifle toward it, giving me a direct hit.
Since Earth is much less massive than Jupiter, its lower gravity doesn't draw in as many asteroids. And the Moon, with only a fraction of Earth's gravity, attracts even fewer. But as the Moon's crater-pocked surface illustrates, infrequent asteroid impacts over a long period of time still means plenty of destruction. Jupiter's ability to pull in comets and asteroids has been on display a lot recently. In 1994, the Shoemaker-Levy 9 comet fragments pounded Jupiter. Scientists thought this kind of large impact was a rare event, something to be seen once every few hundred years. But then another comet or asteroid hit in July 2009. It created a large dark spot and a fireball as large as the Earth.
Seeing two different sets of impactors hitting Jupiter only 15 years apart gives some indication that the solar system might even be busier than we thought.
Then, in June 2010, a third object hit Jupiter, with an amateur astronomer capturing the moment of impact. Would this force scientists to change their estimates and acknowledge that Jupiter is hit by large objects much more often than every few hundred years?
I think that there's not necessarily many more than we thought before, and that's because the object that hit in 2009 was smaller than Comet Shoemaker-Levy 9, and there are many, many more small objects flying around there than there are large objects.
But information about any type of impact, large or small, is always helpful.
To understand the impact hazard on Earth, we need to understand the asteroid population, their orbits. So every piece of information, even if it's understanding how often they hit Jupiter or out in the Jupiter region, contributes to our understanding of the overall population of objects in the solar system and how concerned we need to be about Earth impact.
The major source of that population is the main asteroid belt between Mars and Jupiter. That's where the strong gravitational pull of Jupiter has kept millions of smaller rocks from becoming another planet. But that's not the whole story, and large asteroids are easy to spot and track. we'd probably have decades of warning if an asteroid larger than a mile wide had a chance of hitting Earth. But the smaller ones present a tougher challenge, as the latest information shows.
There's far more small ones than large ones. So if you say the objects that are 1 kilometer or 2/3 of a mile in diameter or larger, we think there's about 940 of those, and we've discovered 86% of the population. If you move to smaller objects, say 100 meters and larger, we think there's about 50,000 of those, and we've discovered 10%. If you move to smaller still objects, 30 meter and larger sized objects, we think there's about 2 million of those objects, and we've discovered much less than 1%.
Better telescopes coming online over the next decade will allow astronomers to identify many more asteroids of all sizes. But a 30-meter or 100-foot wide asteroid on a collision course with Earth might not be discovered until just before it hits. Something that size could still pack a devastating punch. The Earth is covered with evidence of past collisions with asteroids. And today's scientists are working feverishly to figure out what's coming next. They know that enormous space rocks have wiped out most life on the planet in the past.
The good news is that they don't hit very often. It's measured in many millions or tens of millions of years. And they're big enough that through our observations, we know where those objects are, so it have long lead time and warning. It's actually the smaller ones that are the bigger risk because they happen more often and they're harder to find.
Imagine that one of these smaller asteroids is streaking toward a city. It may not be spotted until just a few hours before impact, leaving little time for evacuation and no chance to try and deflect it in space. If it's about 100 feet wide on impact, then it will hit with the energy of a 5-megaton nuclear blast, 400 times more powerful than the atomic bomb dropped on Hiroshima.